Sorry about that. Ran out of time and we were right in the middle of example, so I just want to continue on with this example. And then the other thing in section 4.2 is the intermediate value theorem. And I should be able to finish all that up here in the second video. So far we've got this polynomial g of x equals 4x squared times x minus 1 times x plus 3 squared. And we want to sketch a rough graph of this polynomial. So we figured out the leading term, which is going to include that coefficient of 4, and then x that we see in each of the factors along with the power that we see in each of the factors. So x squared moved here, x is here, and then x with a squared is here. And if we multiply that all together, we get 4x to the 5th. So that leading coefficient is positive. That means the right-hand side of our graph is going up. And the exponent, or the degree for this polynomial, is odd. And what that means is the left-hand side does the opposite. So the left-hand side is going to go down. So the other thing that's going to be really helpful is for us to identify the zeros in their multiplicities. Because if the multiplicity is even, we're just going to bounce off the x-axis. If the multiplicity is odd, we are going to cross through the x-axis. So each of these three factors creates a 0. Since this thing is already factored for us, all we have to do is set each one equal to 0. So if I set 4x squared equal to 0 and solved, I would get x equals 0. And there is a power of 2, so it's multiplicity 2 on that factor. My next factor is x minus 1. If I set that equal to 0 and solve, I get x equals positive 1. And the power on that factor, we don't see a power. And when you don't see a power on the factor, we can always just assume it's a 1. So it's multiplicity 1. And then our last factor is x plus 3. If we set that equal to 0 and solve, we get a 0 of negative 3. And there was a power of 2 on that factor. So again, multiplicity 2. So when the multiplicity is even, we are just going to bounce off of our intercept. When the multiplicity is odd, we will actually cross through the x-axis at our intercept. So I'm going to use all this information right here and draw a rough sketch of the graph. So I know I've got x-intercepts at 0, at negative 3, and at positive 1. Start with just your outside intercepts, because those are going to go off, whatever happens from the graph there is going to go off the edge of the paper, edge of the calculator screen. So on the right-hand side, I'm going up. So on the left-hand side, I'm going down. And now we need to fill in what's happening in between. Well, at negative 3, I'm just bouncing. So I'm not going to cross through. I'm just going to turn around. And then at 0, I'm bouncing as well. So at some point down here, the graph turns around because it's got to go back and hit our next intercept. But again, it's just a bounce. So it's going to touch and bounce back again. And then at 1, we cross. So we can turn around and go up. So the only thing we really don't know is how low these two pieces go in between negative 3 and 0 and then 0 and 1. Other than that, this is a pretty accurate description of what the graph of this polynomial looks like. So that was negative 3, negative 2. So again, bounce means you're going to touch your intercept and then just turn around and go back the way you came. And cross means you're going to actually cut through the x-axis and continue on in the exact same direction that you're going. So if before you're going up, you're going to cut through and keep going up. If you bounce, you're actually going to change. You're going to change from going up, you're going to touch it, and then you're going to go down. So that's what the bounce and the cross means, and how multiplicity tells us what to do with each one of them. The last concept in this section is the intermediate value theorem, which I have a lot of fun with in class because I tell my students The intermediate value theorem is the only time that you can answer the question with I don't know and get it correct, believe it or not. And the intermediate value theorem has a lot to do with what we just saw on our graphs. If we have this polynomial p of x, and we're going to plug in two x values. So let's say that p at a and p at b, those two values, not the a and the b themselves, but the answer we get back after we plug them into the polynomial, the functional value, those functional values have different signs. So one of them is positive and one of them is negative. So if p of a and p of b have different signs, then p of x must have a 0 on the interval a to b. Because if you think about it, our polynomial functions are nice, smooth, continuous graphs. So the only way I can go from negative numbers to positive numbers is to somewhere cross through 0 in between. And I'll show you an example of this. So this value here is p of a. P of a is a y value. It's the output value from the function that we get back after plugging a into the polynomial. And p of b is up here. So p of a is a negative number because it's below the x-axis. P of b is a positive number because it's above the y-axis. And the only way we could possibly connect those 2 points is to go through 0, somewhere in between. So that is a 0. Whatever that is, that's a number that will give us back 0 when we plug it into the polynomial. So what we're going to be asking in these, what we're going to be asked in these problems is, does the polynomial have a 0 on a specific interval? So what we're going to do is we are going to plug those 2 numbers into the polynomial, and we're going to see if their signs match or are different. If they're different, then yes, there has to be a 0 in between. So different signs, then absolutely yes, there has to be a 0. If p of a and p of b have the same sign, whether they're both negative or both positive, then the answer is I don't know. And I'm going to show you a picture on my next sheet of why we don't know. The answer is not no. It's just I don't know. So this is answering the question, do we have a 0 on the interval a to b? So we will find those function values and look at the signs. If they're different, yes. If they're the same, I just told you not to do this, then the answer is I don't know. So let me show you why we don't know. So here's an example of where p of a and p of b are both positive, and there's no 0 in between. So the signs match. They're both positive. And because we have the picture, there's no 0. So we can look and see that there's no 0. But here's another example where it's completely different. Signs are the same. P of A is positive. P of B is positive. And because we have the graph, we see that there are 2 zeros. It goes down and comes back up again. And that's why they're both positive, because we didn't stay down below. Now, when we're asked to use the intermediate value theorem, we're not being asked to look at the graph. We're being asked to decide solely based on the signs of those function values. So if the signs are opposite, then it's a definite yes. If the signs are the same, we have no idea, because it could be either one of these situations where the whole graph stays above, or it dips below and comes back before we're able to check it again. So here they're opposite, opposite signs, and it's a definite yes. This is what the intermediate value theorem tells us. Opposite signs is a definite yes. Same signs, since it could be multiple situations for same signs, we just say, I don't know. So we're going to look at this without the graph. Does P of x equal negative 5x cubed plus 2x minus 3 have a 0 on the interval, let's say -2 to 1. And the way that we're going to check that is we're going to find what the functional value is at -2 and what the functional value is at +1. So we're just replacing all the x's with these numbers. So I've got -5 times -2 cubed plus 2 times -2 minus 3. And that is going to be 40 minus 7, which is 33. This is -2 cubed is -8 times -5 is +40. We get 33. So it's positive. That's the important thing. It's positive. P at 1 cubed times 5 plus 2 times 1 minus 3. Well, that's going to be -5 plus 2 minus 3, which is -6. So it's negative. So this is a definite yes. Those signs are opposite. By the intermediate value theorem, it's a definite yes. Now let's do one more real quick. I'm going to use my same polynomial. P of x equals -5x cubed plus 2x minus 3. Does it have a 0 on, let's say, 0 to 3? So we're going to find P of 0 and P of 3. So if we plug 0 in, we get -5 times 0 cubed plus 2 times 0 minus 3, which is just -3. So it's negative. When we plug 3 in, -5 times 3 cubed plus 2 times 3 minus 3. Oh, this is going to be a big number because 3 cubed is 27. And we're going to multiply that by 5. And I believe that's going to be -135. And then plus 6 minus 3. So that's -132. So at x equals 0, we're below the x-axis because we got a negative. And the x equals 3. We're below the x-axis because we got a negative. So it's I don't know.